Okay, starting our chapter on Introduction to Vectors, we have to review some prerequisite skills here. Some things that hopefully ring a bell for you. The Pythagorean Theorem, c squared equals a squared plus b squared, only used for right-angled triangles. Trig ratios, that's the Sakatoa thing, also only for right-angled triangles. And then Sine Law and Cosine Law, which are for triangles that are not right-angled. So jump right into some problems here. Special triangles may come up in all this as well. Again, hopefully this comes back to you pretty quick. 45, 45, 1, 1, root 2. Notice, not radians here. We're going to go degrees for a little while. And 1, 2, root 3 for the 60, 30 triangle there. First problem, here we go. Switch over to a pen here. Triangle ABC has AB equal to 6, angle B equal 90, and AC equal to 10. Find all the unknown angles to the nearest degree and side lengths to one decimal place. So what I get out here is I'm going to just draw a right angle triangle in here. Put the little right angle symbol in. Since it's a right angle triangle, Pythagorean Theorem is in. Sakatoa is in. So those are the things I'm thinking about. Let's see, they said B was 90, so I'll put a B there. It doesn't really matter where I put the A and C now. AB is 6. Angle B is 90. Yeah, I got that. AC is 10, and they want all the sides and angles. Well, I think for me, I'll go after the missing side first. A little Pythagorean theorem will do it. I'm going to use A squared equals B squared minus C squared. I know those letters don't look in the right spots, but notice they put B over here as the hypotenuse, so I was stuck with doing it that way. So I get A squared equals 10 squared minus 6 squared. A squared equals 100 minus 36. A squared is 64, so A is the square root of 64. I get A equals 8. This question doesn't have any units in it, so it's just an 8. I'll fill that in on my diagram here. I'll just use the sides that were given in the beginning, and I'll go after angle C right there. For angle C, we got opposite and hypotenuse, so I'm going sine of C is opposite over hypotenuse. If I want that angle, I got to go sine inverse of 6/10. Go to my calculator and make sure I'm in degree mode and do sine inverse 6/10. And I get 37 degrees. I think it said, nearest degree, yeah. So C is 37 degrees. I'll put that on my picture, 37 degrees. And so if I want to find angle A, I just go 180 minus 90 minus the 37. Angle A is 53 degrees. If I found everything, all the sides and angles there, yeah. So hopefully that's a pretty quick review of what you do inside right angle triangles. Moving on to the next question. Triangle PQR. R equals 4, Q equals 7, P equals 5. Okay, so I'll just draw a triangle here, which I don't know if it's a right angle triangle. I can't assume it's a right angle triangle. So I get side R over here equals 4, Q equals 7, and P equals 5. Determine the measures of the angles to the nearest degree. Well, I don't know it's a right angle triangle, so I can't use Sakatoa. Pythagorean theorem obviously is no help here. I've got all the sides. So I'm left with sine law and cosine law. Sine law needs an angle. I don't have any angles. So I'm left with cosine law. So what I'm going to do here is write down cosine law. Now look, it says look for the smallest angle first. There's one little thing that can come up in sine law and cosine law is this whole ambiguous case thing. And it comes from the cast rule, and it comes from the SSA case, side-side angle. You can walk yourself into trouble pretty easily if you're not careful with these questions. And a little trick that doesn't come up in grade 10 too much, but hopefully got mentioned in grade 11, was that we should always look for the smallest angle first. We've got a choice. That way we'll know that angle cannot be obtuse, and we don't have any of those ambiguous case types problems. So this one tells me, go ahead, find that smallest angle first. So if R is the smallest side, then R will be the smallest angle. So then I want this version of the cosine law. r squared equals p squared plus q squared minus 2pq cosine big R. Most people memorize it that way. There's another version of this thing, and it just comes from rearranging this. 2pq cos r equals p squared plus q squared minus r squared. And all I've done is moved over the r squared to this side and the negative 2pq over to the left side. And then isolate for cosine of r, and you get p squared plus q squared minus r squared over 2pq, or r is cos inverse of that big mess. And some classes, some teachers sometimes use this one directly, and you sort of memorize this, or you're given this thing directly, but it's just a rearrangement of the original cosine law. And so now I fill in the things that I got here. Cos inverse, p squared is 5 squared, q squared is 7 squared, r squared is 4 squared, 2p is 5, q is 7. Type that big mess in. Now, if you're just following along with this video, maybe you should get at your calculator and make sure you get the same thing as me. My calculator's got a nice fraction button on it, so I can be sure that I'm getting the right numbers here. But if yours doesn't, you might want to make sure you know where to put brackets on yours around the numerator, around the denominator, so you get a right answer here. I'm typing as I'm talking here into my calculator. 5 squared, 7 squared, 4 squared, 2 times 5 times 7, yep. And I get this fraction when I'm done, 29 over 35, and then I'll cos inverse that. Maybe could have done that all at once as well if I'm really smooth with my calculator. I wanted to show you that step in between there, and I get r is 34 degrees. So that's over here, 34 degrees. Now I can use sine law. I don't know if you remember sine law now. I'm going after angle, so I'm going to go sine p over little p equals sine r over r. I like rearranging this thing first, me personally, and going after what I'm solving for. I'm going after p. I went after the next smallest side there, so I'm going after sine of p. So I go r sine p equals p sine r. I want p, so I'm going sine p equals p sine r over little r. And so I got p as the sine inverse of p sine r over r. I think it's pretty convenient to rearrange these things beforehand. Now that you're a little more used to the algebra, it's nicer to sub these things in at the end. So what I get is sine inverse of 5 sine 34 over 4. I'll do that all in one step this time. Sine inverse 5 sine 34 divided by the 4. I get 44 degrees. See, because they were the two smallest angles I went after first, I completely avoided any ambiguous case situations. There's no way those could have been obtuse. And then the last angle I need is the Q, and to get Q, just draw that on there, Q equals 180, subtract the 44, subtract the 34, Q equals 102. See, that one might have caused me a problem if I had gone at it first. My calculator might have told me 78 degrees, and then I would have had to know which one it was by doing some thinking and everything like that. Going after the smallest one avoids all that kind of nonsense when you're given the three-side situation. All right. 3 and 4 to go. Okay. 3. Solve the following triangle. Find all the unknown sides and angles. This one a little bit simpler type situation. This is a perfectly laid out cosine law question, 2 sides and an angle. The reason it's not a sine law is I don't have a matching angle inside, like B and B or A and A or C and C. That's when you'd use sine law. Here, cosine law, so it's B squared equals A squared plus C squared minus 2AC cosine B. So B squared equals 14 squared minus, plus 12 squared minus 2 times 14 times 12 times cos 48. I really like the cosine law, especially great calculators. You can type this all in one step. 14 squared plus 12 squared minus 2 times 14 times, 12 times cos 48. Bingo. I get 115.172163. I'm going to square root that thing. Um, 10.7. And again, no units in any of these questions in the examples here, but if this was centimeters, it'd be centimeters, meters, it'd be meters, whatever. Now that I have that side, 10.7, I can use sine law to get another angle here, and I'll go after a small angle again, the C. So sine C over C equals sine B over B. I'm going after angle C, so I'm going to go B sine C equals C sine B. Sine of C equals C sine B over little b. I'm going to really rearrange this thing. Sine inverse of C sine B over little b. And so, ready to sub in here. Little c is 12. Big B is the 48. And the little b is this 10.7 I just calculated. Here I go. Sine inverse 12 sine 48 divided by 10.7, 56 degrees. That was C, 56 degrees. And I can get my angle A by going 180 minus the 48 minus the 56. A equals 180 minus 48 minus 56 equals 76 degrees, and I'm done. Got everything there. Hopefully these steps seem pretty familiar now that you're seeing them walk through a little bit here. And again, if you had units, again, there'd be units here for the B and just the B, because the degrees are there. Notice we're working back in degrees here, not radians. All right, find the exact value of cos 60. Okay, so if we're finding the exact value of cos 60, we can't just go ahead and type it into our calculator, or at least we're not supposed to. I know if you got a calculator that does it, that's fine, but you really are supposed to know how to do these things for certain angles with the special triangle. So here I'll just draw the special triangle that's got 60 in there, and then that's a root 3, 1, and a 2. And so cos 60 is just adjacent over hypotenuse. I get 1/2. Now you can verify these things if you got a calculator ready to rock and roll, but you really should be able to draw the picture and show what's going on here. And the last thing, tan 135. And for tan of 135, we need a little bit more of a picture because we got to draw it into this quadrant here, because theirs is where 135 would be. And so that gives me a triangle with 45 degrees, 1, 1, root 2. And so for tan 135, I got to go opposite over adjacent, which would be 1 over 1, which is 1. But one little thing, because it's changed quadrant on me, I got to check to see if the positive negative part has changed. And it has here. It's in a sine positive quadrant, so tan 135 is -1. Now you can check that in your calculator if you've got a calculator available, but you really have to know how to show this work. Okay, so even if this stuff seems very familiar, we're going to be using a lot of trig in this chapter, so I encourage you, please, take a run at this homework. Should be a pretty nice relief compared to some of the other calculus stuff we've been doing, so you can jump right in and knock that down, and I'll see you here next